Hi folks, I'm going to go through the solutions to the 3 review problems here. If you have any questions, make sure you just send me an email though. Okay, so the first question says, Angele's plane had been flying through calm skies with no wind with a velocity vector of 400, 100. So we can kind of sketch that out. And maybe I will make her plane's vector blue. So about there, that is the velocity of the plane, 400, 100. Now the wind picks up, and although she has not adjusted any controls, the plane's new velocity, so this is going to be the resultant velocity, is 350, 50. So it's kind of a little bit less in both directions. So I'm going to label that resultant, okay? We know that the wind must be somehow pushing in here, pushing her plane back, that this wind is coming from that sort of direction that would be slowing her plane down. It's going less fast in an east direction and less fast in a north direction. So we want to know what this is actually a little bit nicer than what the quiz question was. This is asking for speed and direction. Remember, speed is just the magnitude of velocity. So I absolutely could have said on this question, what is the velocity of the wind? And you need to remember to give me both parts. So we know kind of in general, if we're talking about these plane kind of questions, that the plane's velocity plus the wind's velocity will equal the resultant velocity. And we know that the plane's original velocity was 400, 100, and the resultant velocity after the wind is 350, 50. So we could say that the wind would equal the resultant velocity minus the plane's velocity. Or you could just kind of analyze and say, well, what would have had to get added to that 400 to make it 350? It's going down by 50. What would have had to get added to the 100 to make it go down to 50? That's going to be negative 50 as well. But we could do it algebraically like this. So we would have 350, 50 minus 400, 100. So the wind would be negative 50, 50. So that is the vector for the wind. We would have to figure out what the magnitude of that vector, oh, negative there, what the magnitude of that vector is for part A. So for A, we want the magnitude of the wind, which is the square root of negative 50 squared plus negative 50 again squared, and that ends up being about 70.7 kilometers per hour. Okay, the angle, which we could, I'm just going to kind of reorient over on here, that this wind vector is negative 50, negative 50. Now I'm going to do the work of this, even though you guys probably are looking at this and saying, oh, well, it's going at a 45-degree angle because it's got kind of basically going down and to the left exactly the same amount. But I'm going to show the work of doing that by kind of looking at where that vector would be. So this vector for wind, just because it won't always be that case. So I would find my theta in there, and we've got negative 50 in the x and negative 50 in the y. So my theta, and I would just use these positive because I'm only looking at the magnitude really. So tan theta is 50 over 50. So theta would be 45 degrees. That also means that the angle out here will also be 45 degrees. So I could say, therefore, the plane, or the wind, velocity is 70.7 kilometers, and that's in the direction of south 45 degrees west, okay, or a directly southwest wind. The next question. So we've got somebody going on a trip in the jungle. Kita left 3 days ago on a journey into the jungle. The 3 days of his trip can be described by these vectors D1, D2, and D3 measured in kilometers. So part A asks how far is he from camp at the end of day 3. So we can sketch this out. So we've got all positive. I'm just going to kind of adjust that to that reality there. So D1 is 8, so 7 kilometers east and 8 kilometers north. So that's D1. D2, he's going 6 and 2, so more that direction. This is not to scale, of course. And then D3, he's going 2, 9, so a little bit east and a lot north. So that's D3. Okay, so we're going to have a resultant vector that I'm going to draw kind of right through there. A resultant that is the sum of his travels over the course of those 3 days. So he went kind of different directions, but where did he end up? So my resultant is D1 plus D2 plus D3, and then that would be 7, 8 plus 6, 2 plus 2, 9. So the resultant ends up being 15 in the east direction and 19 kilometers north. So here we're going to look at what is how far is he from camp. So this is not asking how far he's walked, because he obviously kind of walked longer than he needed to, although I suppose it's a jungle, maybe you have to take some detours. It's not a direct path, but we're saying how far actually away is he from camp. So for part A, I'd say the magnitude of that resultant, which is the square root of 15 squared plus 19 squared, and that would be approximately 24.2 kilometers. And then if we wanted to figure out for part B what bearing he is from camp, so we can sketch this out with his resultant vector of 15, 19. And use that to find the angle in there. Now, I always like to put my angles kind of in the triangle where we kind of form a triangle with the X and Y, even though we're actually going to be looking for that angle there. When we're talking about the bearing, I'm just going to subtract it. So I would say that tan theta is 19 over 15. So then my angle would be about 51.71 degrees. And when I'm getting bearing, I'm going to want to subtract that from 90, which would give me 38.29. So therefore, he is 24.2 kilometers from camp at a bearing of, and I would say 038.29 degrees, or you could say north 38.29 degrees east. Okay, that's also an option for sure. So the true bearing or quadrant bearing is fine for your answers. The last one, when I set these up on my desktop, the page number is in, whoops, different spots. So I always kind of end up having to move them. So here we've got triangle ABC, and we've got some medians. Remember that medians are the lines that you draw from a vertex of a triangle to the midpoint of the opposite side. So those are equal. So AM, so there's M, and B to N, so I'm going to draw that midpoint. These are not necessarily the 90-degree ones. Typically they're not, unless it's like a equilateral or isosceles. And C to P. Okay. We want to prove that AM plus BN plus CP equals 0. So we're going to use a vector proof. I'm going to start left side, right side. Now, this is one where there's a few different ways to kind of go about this. I'm going to list the things that I know just from the setup of the question. I'm going to say that because these are medians, it's going to be really important that that these would be the same length. And obviously they're collinear because they're along the same side as the triangle. So I'm going to say that vector AP equals vector PB. And that also equals, both of those equal 1/2 of AB. So I'm saying that this vector here and this vector here are equal, and that each of those would equal 1/2 of the full vector AB. So I think that that's pretty straightforward. I'm going to state the same idea for the next two sides. So I'm going to say vector BM equals vector MC, and that both of those are equal to 1/2 of vector BC. And likewise for the third side, vector CN equals vector NA, and both of those are equal to 1/2 of CA. So going up to my proof, now these are all things that I can use when I'm doing my proof. So I'm going to want to write out AM, BN, and CP as different things, vectors along the side lengths, because I don't know a lot about what's going on through these centers, but I do know, especially since I want this to equal 0, I know that if you go all the way around a triangle like AB, BC, and CA, that would equal to 0. So that's what I'm going to try to use here. So instead of AM, I'm going to write AM as AB plus BM. And then instead of BN, I'm going to say that BN is equal to BC plus CN. So I'm just changing these to all around the outside of the triangle. And sometimes people kind of hit a bit of a dead end depending on which path you take, but really just keep trying it. If something doesn't work, just try a different route of kind of explaining what that vector is equal to. So here I have vector CP. I'm going to go CA and AP. Oh, plus CA plus AP. So remember what I said about I know vector AB plus BC plus CA has to equal 0, and I see those. I have AB, BC, and CA. But I've also got a bunch of other stuff. I've got these 3 other terms. So I want to put those in terms of AB, BC, and CA, just like I've stated down there. So instead of BM, I'm going to write that as 1/2 BC, and so on. So I'm keeping the AB. Here I'm replacing BM with 1/2 BC. And then I still have BC. Now I'm going to make a replacement for CN and call that 1/2 of CA. Then I still have a CA, that's staying the same. And then where I have AP, I'm going to replace that with 1/2 AB. Okay. Now I see a bunch of like terms, and I'm just going to like highlight them like what you would have done when you were in grade 9, like learning like terms. So there we have AB plus 1/2 AB. So that's 3/2 AB. Then I've got 1/2 BC plus BC. So that is 3/2 BC. And then we've got 1/2 CA plus CA, which is also 3/2 CA. So we can factor out that 3/2, and we get AB plus BC plus CA, which we knew this thing went around the triangle A to B, B to C, C to A. We're back where we started, so that's the 0 vector. So here we get 3/2 times the 0 vector, which is 0. So we've got our left side equal to our right side. We have done it. So that's all for the review, guys. If you have any questions, shoot me an email. Thanks.